So we're going to be working some more with ratio tables. That's gonna be apparently a big thing on the check-in that you guys are gonna be taking next week. So we wanna make sure that you guys have a good, complete understanding of ratio tables. So it says, how is it growing? So it's gonna be our warm-up today. It says, look at the pattern in the figure. How many total tiles will be in the fourth figure, the fifth figure, and the 10th figure? And then how do you see it growing? So you and your table mates can kind of answer A, B, C, and number 2, okay? So you guys are working together to answer those 4 questions technically. I'm gonna give you, say, 3 minutes. Aiden, you didn't submit your quiz yesterday.
Oh, I thought I did.
Yeah, just open up your iPad real quick and submit it for me. Also, so you guys know, the top 3 here are green, the bottom 4 are blue. For this one, top 6 are green, bottom 8 are blue. And then same thing for the last one. Yes, no, maybe. Alright, so let's go ahead and go over this together. So, how many tiles are going to be in the fourth figure? What you guys come up with? Troy?
21.
21. Anybody come up with something different? Did you come up with that?
28.
Okay. Anybody else come up with something different?
27.
27. Alright, so Troy, you came up with 21. How did you come up with 21?
Because I noticed every time it grows, it adds, it adds 4 every time it grows, so I figured since with the third finger, I'll just add 3 on the top and 1 on the side.
Okay. Okay, alright, Bella, what'd you guys do?
What we did is, because we noticed that it actually adds on 7 because it adds one of the blue and then it adds one of the green. So we noticed that it goes from 7 to 14 to 21, so then we just added 7 on to the fourth figure and it's 28.
Okay, so essentially you're saying you're increasing or you're skip counting by sevens
Yes.
in a way, okay? Alright, Emma?
I miscounted.
Okay.
I double checked my math and I miscounted.
Alright, so Troy, you were on the right track with the adding the 3 and the 1, but just be careful because we add 3 here and 4 here. 3 here, 4 here, 3 here, 4 here. So yes, you are increasing by 7. So for the fourth figure, you're gonna have 28 tiles. Alright, what about for the fifth figure? What are you gonna have there? Christiana?
35.
Alright, and then what about the 10th figure? Wait,
70.
70. And did you guys all use the same logic of I'm just gonna add 7 and 7 and 7? Or did you guys start multiplying by 7? You multiplied by 7? So did you take like 4 times 7? And then, listen, 5 times 7 and then 10 times 7, okay? And there is no right or wrong way to find 28, 35, and 70. It's just different ways to find those. All right, and then obviously we kind of figured out how does it grow? So how does it increase each time running?
By 7.
Oops. Very great. All right. So just making sure that you do have a complete explanation there on the bottom. All right, so let's go ahead and look at the next part of what we're going to be doing. It says a huge amount of sparkling orange juice. So Noah's recipe for 1 batch of sparkling orange juice uses 4 liters of orange juice and 5 liters of soda water. So sliding over here, it says use the double number line to show how many liters of each ingredient to use for different size batches of sparkling orange juice. Alright, so what's the first number we're going to put on our double number line? What's the first number we put on any double number line? Let me say it that way. Or any number line in general if you're starting at a starting point and going in one direction or the other. Mila?
Original ratio.
Before that. Alright, so we're going to start with 0 on the top, 0 on the bottom. Then we're going to do the original ratio as Mila told us. So how many liters of orange juice is Noah going to use? Noah, how many liters of orange juice are you using?
34.
What did you say? So look over here on the bottom,
Oh,
because that's our original.
4 liters.
Alright, so we're doing 4 liters here, and then how many liters of soda water are we going to use? How many liters, Emma?
5.
5. Alright. So at this point, what number goes in the middle? How many batches is 4 liters of orange juice to 5 liters of soda water? How many batches is that? It's 1. So we know we multiply by 1. I want you to fill in the rest of the number lines. Okay, you can work with your partners or you can do it on your own. When you are done, stand up for me. Stand up when you're finished. Give you about another 20 seconds or so. Ten seconds. All right, have a seat. So for the next one, what are we multiplying by? For this next one, what are we multiplying by? Troy? 2. So 4 times 2 is 8, 5 times 2 is 10. So the next one we multiply by 3, so what do we get? Brownie? 12 to 15. The next one is multiplied by 4, what do we get? Kaya? 16 to 20. All right, the next one, what do we multiply by? Krishana? So what do we get? So what do you notice about the numbers on the top? What are they increasing by? Mila? 4. And the numbers on the bottom? Increasing by 5. All right, so we have 24, 28, 32, 36, 40. Down here we have 30, 35, 40, 45, and 50. So, number 2 says if someone mixes 36 liters of orange juice and 45 liters of soda water, how many batches would they make? So how do we figure out the number of batches that we're making? What number represents that? Okay? The number in the middle. So if I continued going, I'm going to figure that out. How many batches can you make with 36 liters of orange juice? Excuse me, 45 liters of water, or soda water. Jonathan?
You would need
9. So you would be able to make 9 batches, so essentially this is times 9 right there. All right, if somebody uses 400 liters of orange juice, how much soda water would they need? So now this is the question. What do we do? Because our number line stops at 40 and 50. So we're gonna keep drawing this crazy number line to 400? No, absolutely not. I mean, by all means, go ahead, but I'm gonna be here on Monday of next week, and you'll probably still be sitting in that same chair, trying to get your number line to 400 and to 500, right? If you actually did your tick marks and all of that, it would definitely be you'd be here for a while. All right. So what's another way that we could possibly do this without using a number line?
Either divide 400 by 4 or multiply 5 by 100.
So she said either divide by 4 or multiply by 5 or 4.
Because when you're done dividing whatever the answer is, because you would have to multiply that no matter what you do to the 5.
Right. So what does that sound very similar to that we've kind of already talked about? If you go back in your notebook to, hold on, we're gonna get there. This page. Sounds a lot like that, doesn't it? When we multiplied our original ratio and divided it, what was this called? What do we use here? What is this thing right here called? It's a chart or a ratio what? Ratio table. So you could also use a ratio table for the question that we're working on right now. Obviously, we're just gonna do it kind of simply and,
Oh, perfect.
do we wanna multiply by using 4 and 5, or do we wanna divide using 4 and 5?
Multiply.
Gonna multiply? Alright, so what am I gonna multiply 4 by to get 400? What am I gonna multiply 4 by to get 400? Let's just turn it into the technically, we're not in the middle of class now. It's okay, you can just submit it, or you can keep just trying to figure out, but I'm not gonna stop teaching for that. Okay? Alright, so what are we gonna multiply 4 by to get 400, Troy?
100.
100. So 4 times 100 gives me 400, correct? So then, Troy, what am I gonna multiply 5 by?
100.
Why?
Because it's the same as the
Right. You're exactly right. So if we multiply by 100 to one number, what do we have to do to the other number? We have to multiply it by the same thing. Alright, so 5 times 100 is going to give us 500. So we would need 500 liters of soda water. Okay, that is a lot. It's a whole lot. Alright, your next question, it says, if someone uses 455 liters of soda water, how much orange juice would they need? So for this one, what are we going to do? So for this one, what are we going to do? So if somebody uses 455 liters of soda water, how much orange juice would they need? So what do we do here? So if we multiply here, what are we going to do here? Or let me ask you this. Why was it easier to use multiplication with this one? Like why was it just, to me, I feel like it was much easier to use multiplication with that one than to use I guess either one of them could have been, but, what do you think, Troy?
because for simple math is 100 times 5.
Right, it's simple math. So now we're looking at the number 455, it's not as simple. And we're also going to be using soda water, so is that 4 or is that number 5? Like, is it the 4 or the 5 that we're using? We're using the 5. So how many of you guys feel like doing division would be a little bit easier here? Okay, so I want you to draw an arrow down here, and I want you to do 455 divided by 5. Stand up when you have your answer. Sorry. Just hop over to this, and then I'll come over. Alright, Elise, what'd you get? 91. So essentially, we're going to make 91 batches of this. So if I did 455 divided by 5 equals 91, how do I use that 91 to figure out what I'm going to need for the orange juice? What do I do there? Isaac, what am I going to do there? Am I going to multiply or divide? Alright, so I'm going to do 91 times what?
5.
Well, so this is our soda water. We're trying to find the orange juice.
4.
4. So I'm going to multiply this by 4. That gives me 436. So how many liters or how much orange juice are we going to need? How much orange juice are we gonna need, y'all? Answers on the paper, all you gotta do is read the number. Tyra. It's right here, baby. How many liters are we gonna need? 364 liters of orange juice. Alright, so for number 5, it says explain the trouble with using a double number line to answer the last 2 questions. What was the problem? Like, what made 3 and 4, or what would have made 3 and 4 really hard had we continued using a double number line? Aiden.
The number line would be too like big.
So the number line would be too big. And what else? I mean, think about how neat or not neat some of you guys are. Like even this number line up here, with it being smaller, your numbers get real squished together, don't they? Alright, so what else is another reason that maybe that double number line wouldn't be that good? Kaya?
We also take
A ton of time. Anything else? Ronnie?
it would take too long to draw out 400 ticks or something like that.
Okay, so that goes along with taking a ton of time. Anything else we want to say that this would not be the best thing to use? Alright, so we're going to change that to a period. Alright, flip your paper over. Now, you're going to notice that we've already done this table. We did this table last week on the page that I showed you earlier that we can refer back to. So, all we're going to simply do is refresh our memory by multiplying or dividing, just to kind of get the table back in our minds. So even if you want to flip back to that page that we did this on, that is fine to help you out. So our original ratio is 7 almond ounces to 5 raisin ounces, or ounces of raisin and ounces of almonds. So how do I go from 7 to 28? How do I go from 7 to 28? Ronnie?
We multiply by 4.
So I times this by 4, which
Times the other side by 4.
which gives me,
20.
alright. How do I go from 5 to 10? What do I do? 5 to 10, Kylie.
Multiply by 2.
So multiply by 2, so that means 7 I have to multiply by 2. What is 7 times 2? What's 7 times 2? Well,
14.
14. Alright, how do we go from 7 to 3.5? How do we do that? Belle,
Divide by 3.
not by 3.
10.
Divide by what? It's half of 7, so what will we divide by? 2. Okay, and then so same thing over here, we have to do 5 divided by 2. What's half of 5? Joy?
2.5.
Alright, then what do we multiply 5 by to get 250? Where's Shauna?
50.
So this is going to be times 50, which means I have to do times 50 here. What's 7 times 50? 7 times 50. Kaya? 350. And the last one, what is 7? Or what times 7 gives us 56? Or we can divide 56 divided by 7. Either way. Emma?
9.
Sure?
I'm confused.
Okay, that's fine. What is it?
8.
8. So we're going to times 7 times 8 to get 56. Then we times 5 times 8, what do we get? What do we get? Christiana? 40. Alright, so essentially we're going to cross out those two questions. And I'm going to ask a question. And we're going to write our answer down here. So really we're going to cross out number 3 too. We're going to write our answer down here. So my question to you is, why were we able to, well, let's talk about the ratio table. So you notice with the ratio table, do you have to go numerical order? No, you don't, right? Like, so with the double number lines, we have to go 4, 8, 12, 16, 20, 24, right? We have to go in order like that. With our ratio table that we just revisited, did we do that? No, we kind of went wherever we needed to go based off of what the information was in our table.
And like 20 to then.
Right. So with a ratio table, you don't have to go in numerical order, so that's a good thing. What else do you notice about the numbers that we filled in? So 7, 28, 14, 3 and a half, 350, 56. What do you notice about those? Ronnie? So they're multiples of our original ratio, okay? Are they really big numbers? So 350 isn't a fairly big number? And small numbers, because we also have, so we have 350, but we also have 3.5. So a ratio table allows you to be able to do what?
Have big and small numbers?
Have all kinds of numbers, and they're not just certain numbers. So how is a ratio table sometimes better than a double number line? That is what you're writing right here. So I'll say it again. How is a ratio table better than a double number line? Stand up when you have your answer. Alright, so who would like to share why the ratio table can be better than the number line? Just, it's not, like, it's not. Jonathan?
Because in the ratio table, you don't need to go in order. You could just multiply by any number.
Alright, what else? Ronnie?
It's also faster
Why?
because we can go to, for the first one, it went 7 to 28, which are kind of small, and then it jumped to 350. So you can go to big numbers in less time.
Okay. Alright, so it's definitely faster, more efficient. Alright, what else?
It's more organized.
More.
To squeeze a bunch of numbers.
Okay. Alright, what else? What was another reason you guys felt like it was better? Emily, what'd you write?
It's not like that complex.
Okay. What else? As in put it away, sweetie. Now. What else? Nobody else has anything else to write? How many of you guys feel like you still like the double number line better? Okay. Why do you like it better? Just like it better? Okay, fair enough. Isaac? Just like it better?
It's less messy.
Okay, I do agree with that, because there's lots of arrows and numbers come to the side, so I get that as well. We are done with this lesson for today, so what I want you to do is I want you to fold it in half, and you're gluing down, nope, you're not gluing down the summary. I want you guys to glue down the Are You Ready for More today. And the reason I want you to glue that down is because I want you to be able to see the summary today. Why do you think I want you to be able to see the summary? What does the summary talk about? Ronnie? Well, it talks about what we did, but it's also showing you what on the summary? What's it showing you? Guys, what does the summary show us? Stop what you're doing and answer the question. Zoe, what does the summary show us? Shows us what? Guys, what is on the summary page? Like, I'm not asking for rocket science. What is on the summary page right here? Emily? Yes. So it's showing you both. You need to know, you need to see, you need to understand. Double number line, table. Now, the table, obviously, they went in order, as well as with the double number line. You do not have to. When you are done with your cool down today, please turn it into the first period.